Hello everyone, this is Dr. August de Oliveira, and I have a interesting case, me. I was born without number 20 and 29. I had some baby teeth that were extracted, and now it's time for me to get implants. So I'm planning my own case. So here I am in Pylon, in Pylon, we start always with the crown. So here's the crown forms. You can see here they're a little bit bigger than the average tooth number 20 or 29, simply because I had retained baby teeth and those molars are wider. So we just left click to move the tooth. If we hover over these red dots, we can rotate the tooth. And if we grab a hold of these little points, we can scale the tooth. So we have our teeth in here. Underneath the implant section, I've already gone ahead and planned this case, but I'll go over the steps. So we've got two implants. These are 4.5 by 10 millimeter Urus implants, which are awesome. And so we've planned the implant. One thing that I always do is I turn on the implant axis. And this really kind of gives me the ability to center my implant in the crown form that I have. So if we look over here, I'm going to go ahead also and turn off my guide sleeves. So we can see that I'm in fact in the center of tooth number 29, and I'm kind of off to the buccal on tooth number 20. Looking at my crown form, I plan this maybe a little too lingual anyway. So one thing that's always great is we can always just pop around in Pylon and move those teeth out a little bit. And so we can look back, and yes, that's looking pretty good. Maybe I'm angled a little bit too much to the mesial. So I'm going to turn my cone beam back on and change the angulation of my implant just a hair and get that lined up pretty good. And so we can also pop over. One warning that you're always going to get is that you have collided sleeves. And if you think about it, let me just go ahead and turn off my cone beam, turn off my crowns, and turn on my guide sleeves. So what Pylon is saying is my guide sleeves are hitting something. And Pylon doesn't know if that's gum tissue or that's actual bone. It is in fact gum tissue. We're going to be doing little flaps, so I'm not worried about that collision. So if we pop over here to designing the guide, I've already designed my guide, but I'll go ahead and do it again for you. So I'm going to go ahead and delete this and delete my guide and start from scratch. So what I like to do first and foremost is think about my path of insertion. And so this is going to be a full arch guide. I usually do quadrant guides, but since I've got two implants, might as well do it all in one shot. So we get the path of insertion. I'm going to look here at the parameters: guide's thickness 2.5, offset from teeth to guide 0.1, offset from sleeve to guide is 0.05, and I like to also change the Z to 0.05. The offset from teeth to guide is the spacer underneath your surgical guide. The offset from sleeve to guide is the spacer around the hole and the sleeve. So I'm going to go ahead and start by clicking this plus sign over here. And I like to extend to the second molars, but not the distal of the second molars. This is a hard area to scan. So what we want to do is when we draw our little line here, I like to kind of stay away from any blocked out undercut areas, or Pylon will give you some grief. And so we'll come back up here, back down here, and I'm going to avoid those little shaded areas and come back over here and double click. And so I can go ahead and click Generate Surgical Guide. And we got our guide. One thing I didn't mention, if I pop over here, one thing that's really important is to think about what type of scan body you're going to be using. So when I pull up this little menu, you're going to come all the way to the right under Abutment, and you have a choice between the Urus Omni Scan Post, which is a CIREC thing. Going to be using Exocad to design my custom healing abutments, so I always want to make sure it says Urus Scan Body on both implants. So back over here to my guide. So I got my guide, and it's covering a lot of stuff, and it might be tough to see if things are seated. I mean, we've got windows on these teeth here, but let's go ahead and add a window. So if we come over to the bar window creation tool panel, I'm going to scroll down to add window, and I'm going to put a small window in the anterior. What this little thing does, if you remember Mesh Mixer, there's something called Boolean subtraction, which is a funny word. So basically it's going to take this little block and it's going to cut a hole in the guide the size of the block. So I'm going to make this kind of small. And so now it's kind of shoved in to my guide. I'll just make sure it's shoved in all the way. And then go ahead and create surgical guide. So now we've got a nice little window. We're going to pop over here and we're going to accept the approval, accept the planning, and we're going to come down here to export mesh files. And we're going to export that. I always export everything to my downloads because I know I can just go ahead and get rid of it. So I'm going to hit OK. Now if I pop over to my downloads folder and I'll open up D'Oliveira Mesh, and we'll just use Mesh Mixer for this. But I can go ahead and I can see that I've got my lower jaw, I've got my surgical guide, and I've got this union of scan body. And if I go ahead and open up that file, you can see here that I've got a model with scan bodies, and we're going to pull that into Exocad and design our custom healers. Okay, so now we're in Exocad. I'm going to select 20. It's going to be an anatomic crown. We're going to 3D print it, and we're going to call it a screw retain crown. Even though we're doing a custom healing abutment, we always start with a crown. If we wanted to use this as an immediate temporary, we certainly could, but it's a posterior tooth and it's me, so I want to make sure that I don't do that. So I'm going to hit OK, and we're going to just drag that over to 29 and hit save. So I'm going to come on down to my downloads folder. It's asking for a lower jaw scan. And I'm going to click lower jaw. It's asking for a scan marker scan. That's a union of scan body. And our upper jaw as well. So something weird happened. Usually the lower matches pretty good. And this might have been since it's an older case, but it's a good teaching moment to show you how to align meshes. So I'm going to go into Expert, and I'm going to turn off my antagonist for now, and I am going to go to Tools, Align Meshes. So I'm going to go ahead and just move this one over so it's easier to see. And then I'm going to click on Automatically, and we're just going to pick some common points. The floating mesh is going to be the messed up scan marker scan, and the fixed mesh is going to be my lower jaw, which is in occlusion with my upper. So I'm going to perform alignment, and then I'm going to hit Best Fit Matching. And it matched it up, and it's all blue. If you look at the heat map, that means a perfect fit, so I'm going to hit OK. So now we're good to go. We can go back into wizard mode. Scan data orientation. I usually like my anterior teeth on the top of the screen, posterior teeth in the bottom of the screen. I don't want to see any red, so we're just going to align it here and hit Next. Detecting implant position on number 20. So we're going to go ahead, and this is a Urus regular FDA. My option here. So we have a choice between a Urus base with a gingival height of 1 or a gingival height of 2. So these implants were placed fairly deep, so I'd like a little bit more of my emergence profile to be made by the tie base, so I'm going to hit a GH2. And this is really cool. This gives you the option of the spacer around the tie bases. Most implant companies give you the default zirconia spacer setting. We need a little more wiggle room when we 3D print, so I'm going to select 60 micron. And so now I'm going to rotate this model so it looks like this here. I'm going to cut this so it sort of matches this. I'm going to hit Control and click, and it should go ahead and match these up. My computer's acting a little slow. We've got a perfect match at blue. We're going to hit Next, and we're going to do the exact same thing to the other side. Same deal, same size, cut that a little bit so it matches the model here. Hit Control and click, and let that think for a second. And I didn't hit Control in time, so let's try that again. If you don't hit Control, you don't get the heat map, so let's let it do its thing again, and voila, we are in fact cool here. One thing that you can do is you can turn off the scan abutment scan, and you can rotate this so the anti-rotational feature is in a predictable spot. And so let's just make that a little translucent. So I can rotate this so that my anti-rotational is always on the lingual. I don't know why I picked the lingual, I just do. So this is going to be back here. Now it's asking me to define my emergence profile. And you can see here that we haven't actually placed the implant, so I really don't have an emergence profile. So I'm going to skip the emergence profile on both teeth. So it placed a model tooth on 20. It did a pretty good job. Let's go ahead and have it do the same on 29. And looks like it did a pretty good job there as well. So not a lot of work to do. We're going to hit Next. Abutment bottoms, we don't have gingiva to go off of, right? So I don't want abutment bottoms. I'm going to go ahead and get rid of everything here by going into profile borders and just get rid of that abutment bottoms. I want to be able to freeform the entire thing. So we'll hit Next. So now we have two crowns. They look a little lumpy bumpy, so we're going to play around with that. So I'm going to go to Add Remove and sort of build up this area here. Do the same thing over here and build up this area here. And then just go back and we're going to smooth that all back. Do the same thing here. So having that gingival height of 2 makes it just kind of easier for me. Looks like I need to add a little bulk here. So I'll add a little bulk here and smooth that back as well. A little fat here on the buckle. I'll take that down. A little fat here on the buckle. Keep in mind we're cutting off the occlusal, so we should be just fine. We'll turn our jaw scans back on. And we can even play with the contacts a little bit by using tooth parts and kind of move that down. And we can move that down as well. I'm not too worried about occlusion or contacts because we're going to be cutting these off at the gum line. So it's going to get mad at me and say, hey, you didn't do all this stuff. And I'm going to say, whatevs. We're going to allow Exocad to use its defaults for the screw holes. Great. So now I've got 2 screw retain crowns. I'm going to go ahead and right click this one, save to file. I'm going to call that an STL, and I'm going to call it 20 abutment. Original coordinate system of data. I'm going to do the same, save to file, and call that 29 abutment, and hit save. So now we have our 2 crowns. Okay, so we are in Rayware. I'm going to go ahead and call this August's abutments. And I'm going to print these in pink, basically. So I'm going to come down here to base. I'm going to use a Pro 55 for this. And I'm going to use Sprintray Apex base. And maybe I'll do a original pink and upload our files. So Rayware went ahead and put supports where it thought we should have supports. Again, you can see the anti-rotational feature on the lingual on both of these, but this isn't going to work, right? So I'm going to go into orientation, and I'm going to select base. And I'm just going to take this little arrow so that it's flat with the flat portion that is going to engage my tie base. I'm going to click that. I'm going to change the Y to 180 because I don't want to print it like this, and hit enter. I'm going to confirm change. And I'm going to do the same thing over here. This is the same way I print crowns. I'm going to select base, 180, and hit that, confirm changes. So these are crowns, right? So I guess I could take a burr to this, but I'm lazy and I don't want to do so. So we're going to go into Mesh Edit, and we're going to start the plane cut, and we're just going to move this plane cut to sort of below the contact areas and hit confirm changes. So that one's cut. And then we're going to do the same thing over here under Mesh Edit, start plane cut, and go ahead and cut that underneath the contact areas, confirm the changes. So it went ahead, it's printing flat. I guess you could do that, but there's some distortion in the first few layers if you're printing flat. So I'm going to go into supports, and I'm going to say yes. And do the same here under supports and say yes. So this is printing on a standard build plate. It's going to take 22 minutes to print. And there you have it.